The date is 13/09/2021. This is lecture number 2, signals and systems, right? Okay, so what we will be dealing today is the power of a signal. Right, let me call it xt. So this xt can be complex or it can be real valued. So this x of t can be a complex signal, complex valued signal, or real valued signal. Right. So as we already said that power is energy per unit time. So I have a signal x of t, which is a function of time. It can take complex value or it can take real value as well. And we want to find out the signal power, right? So what we say is this average power. So in general, signal can start from minus infinity and can go up to plus infinity, right? So xt is something here, t can be between minus infinity to infinity. So what we are interested in, we are calculating the power over all the time, over time period of infinity, right? I should say. So we denote it by what? P infinity. P infinity. Infinity is just to say that for overall, all the time, for all time, right? And the power is given by in the limiting form, right? So what is that limiting form? That is limit t tends to infinity, and then 1 over t, and this is minus t half to plus t half, and then we have xt, and since xt can be complex, so we take the mod of this and we square it, and its integration with respect to t. So this is the formula to calculate power of a given signal, right? Now, if you observe this formula and compare it with the energy, what we can say about this? It's a time average, because you are averaging over time. This is 1 upon t is there for that reason. We are averaging, right? So it's about time average of signal energy over all time, right? If you remember, what is the energy formula? It was given like this, that is E infinity. You already have seen that, right? So I'm just rewriting that, minus infinity to infinity, and you write mod xt square dt. I can write it like this also, limit t tends to infinity, and I can start from minus t half to t half, and then I can write it like that. So in the limiting form, right? So this is what energy, that we just integrate the square term of xt and we get the energy. Now we are dividing this thing with time, this time period, right? So we are averaging in that sense, correct? So time average of signal energy over all the time. And if signal happens to be periodic, right? If this x of t happens to be periodic, so it can be a periodic signal. It can oscillate, you can say, after a certain time period. Periodic with time period. Let's say t naught, right? Then P infinity, that is for periodic signal, right? For periodic signal. This formula becomes 1 over T naught. T naught is a time period. Here this T is not a time period, right? By the way, capital T is just a constant. You can say, you can just think like capital T is, it's not a time period. It's just a time, and we are letting it to be infinity in the limiting sense. And T naught, I've written T naught, it's a time period. So 1 upon T naught, and you can integrate for one convenient time period. So we generally denote it by T naught. So this integration is over a convenient time period T naught. It can be like 0 to T naught. It can be like minus T naught half to plus T naught half. It can be like T naught to 2T naught. Till the time interval that you are taking is one time period. This integration is going to give you the same answer, right? 1 over time 1 over T naught integration over one time period, and then I will have mod of xt square dt, right? And for periodic signal, I can use this formula. I don't need to use this limiting definition. But again, this limiting definition is for all kind of signals. The signal may be periodic, the signal may not be periodic. So you can use this equation for periodic as well as for non-periodic. But this one is only applicable to periodic signal. Right, what it says, you calculate the power for over one time period, and this average, or you can say this average power is going to be equal to the total power over for entire duration. This is a little bit strange, right? Strange means what? I should say why I'm saying this. So if somebody asks you, let's say, just let me give you a cosine wave, a sine wave or cosine wave. It's a never-ending signal. So it will start at minus infinity and go up to infinity. What it says, the total power present in this entire signal, over entire duration, is exactly same as when you take or when you calculate the power for one time period. Are you getting this point? So this is what you can think like what for periodic signal, right? Average energy per period, per time period, is going to be same as average energy over all time, right? So this is the meaning to this. So to calculate the power of a periodic signal, you can work only on one cycle, and you can say this for one cycle, this is the power. So for overall time, this will be the power, right? One can prove this. It's not that much difficult, but we will not go into that now. We will give you the notes in that we may provide the proof, right? But this formula is for periodic as well as non-periodic, applicable to both. Periodic and non-periodic. I hope these two formulas are understood to everybody, and we just need to figure out how to use them. One more thing, this P infinity, just let me write those terms. This P infinity, that is the total power or average power. It has some different names also, like we call it mean square value. We call it mean square value. Shorthand notation is what? MSV. And everybody knows that when you take the square root of mean square value, what do you get? When you take the square root of RMS value, right? So this is called as a root mean square value. You take the root of mean square value, you get root mean square value. So these names are important because sometimes we get different word problem, but the question is just to calculate the power in that case, right? So it's average. If you see this for periodic signal, it's the average energy per time period, per period. And for aperiodic signal or non-periodic signal, uh, this has no meaning, right? Average per period is not going to be useful because there is no such kind of time period for non-periodic signal, which does not oscillate at all. There is no meaning of what is the time period of that, right? So this is something what the calculation of power, right? It's average quantity. Energy is not average quantity. Energy is just integration. But power is an average quantity because you divide it by time, right? So it's average, time average. Okay, so let's take some questions and try to solve it because and we all know this and the answer we already know, right? And let me just write some of the questions. Let me take this x of t. Let's say it's a sinusoidal signal. A cos 2 pi f naught t plus some phase theta, let's say. So here f naught should not be equal to 0, right? F naught can be anything but not 0. And we want to calculate the total power. I think everybody knows what is the answer to this. What is the answer? What is the power in sinusoidal signal? I think you have learned it in basic electrical or physics somewhere. Yes?
A square by 2.
A square by 2, right? And if you find the RMS, this will be square root of P infinity. This will be A by root 2 because A is the peak voltage. You call it peak amplitude. So peak amplitude divided by root 2 will give you what? RMS. We all know, right? But this is one of the very useful derivation to do this, right? So let's just go through it. And what is I have to apply? Since this is just you need to figure out what is it a periodic signal or not, right? So I can say since xt is periodic, right? It's a periodic signal. You can see this from there that it's a periodic signal with time period of t naught. And if you compare t naught with f naught, what do you get? 1 upon f naught is the time period, right? So t naught is basically 1 upon f naught. So wherever I require, I will replace f naught with t naught with f naught, right? This is how they are related, cyclic frequency and the time period. Okay, so I can use the second formula for periodic signal, how to calculate the power, which will be 1 upon t naught. Eventually it is minus t naught half to t naught half because we have to integrate for one time period. So minus t naught half to plus t naught half, it will be a one time period length, right? And then you have a xt square, right? So if it is the real signal, then there is no need of mod sign. Mod sign is required in case of complex, but this is not a complex signal, so I can directly square it without taking the mod, right? A square cos square 2 pi f naught t plus theta, and this will be dt. This will be 1 upon 1 over t naught minus t naught half to t naught half. And you can just break this cos square into two terms, which will be 1 plus cos 2 times this quantity. So this will be 4 pi f naught t plus 2 theta. And then I have dt. And then divided by 2. What I used here, that cos square is nothing but what? 1 plus cos 2 phi divided by 2. That's the identity that I've used, trigonometric identity. Now I have two terms, so I can just do it like 1 upon t naught, and then I can integrate minus t naught half to plus t naught half, a square by 2 into 1. So this will be a constant, so I can write it outside, a square by 2 and this is the integration of 1 actually, and plus again I have a square by 2 multiply with this cos, this is minus t naught half to t naught half, and this will be cos 4 pi f naught t plus 2 theta dt. One can easily solve this integration and can say that this quantity will be 0, right? So this integration will be 0. So I will not do that. You can just figure it out. For one time period, this integration will go to 0, and this should be right, because you have when you do integration, then how much you accumulate negative area with the same positive area you will accumulate when you integrate it for one time period. So a square by 2, and this is 1. One integration will be t, and the limit will be minus t naught half to t naught half, and this is 0 already. So I have just 1 upon t naught a square by 2 t naught by half minus of minus t naught by half, so this will be plus t naught by half. I'm just writing all the steps, but that is not required. So this will be t naught, so this t naught got cancelled, and I got a square by 2. So this is very simple proof. Once in a life, everybody should write down the proof or do this proof once in a life at least, right? So that anytime when we require some kind of analysis, then we should be able to do this. Now this term is 0, and what is the logic that I have applied? Everybody knows this, right? This integration is 0 for one cycle. Sinusoidal signal will give you 0. What this is as follows. I have a signal, suppose some sort of cosine wave, right? So I have this cosine wave. Sorry. So I have drawn only 2 to 3 cycles. The time period is t naught. So this time period is t naught, which will be eventually going to be 1 upon f naught. Now, what about this is something what cos 2 pi f naught t and plus some angle, right? I've not drawn this vertical axis, so phase can be anything. Okay, so this is what cos 2 pi f naught t plus theta. Here f naught is the frequency. I have the cosine wave, which is 4 pi f naught t. I have drawn here is a cos 2 pi f naught t, but now I have what? Cos 4 pi f naught t plus 2 theta, with some phase. But what you see here, this 4 f naught is there, right? So it means if its frequency is f naught, then what will be the frequency of this? This will be twice. So this cosine wave will oscillate twice at the speed of 2 times than the speed of this. So its speed of oscillation will be bigger, and how much it is bigger? So exactly twice. So if one cycle, it will take this much time. So in that time, it will oscillate it will have 2 cycles, right? So in other words, I will have 2 cycles in that time period. 1 cycle, and this is a 2 cycle. 2 cycle. So you see, this is 1 cycle, and this is 1 cycle. And here in that time period, it's only 1 cycle. This is t naught, right? And if somebody asks you what is the time period of this is going to be t naught by half. Why? Because when you take inverse of this 1 upon 2 f naught, you should get time period. So what is f naught? 1 upon f naught is a t naught, so this will be t naught by 2. So if time period of this is t naught, then time period of this will be exactly half, right? It will take lesser time to complete the cycle, and it is exactly half of the previous one. So there are 2 cycles. Similarly, I will have again 2 cycles. So you are right. That's fine. So there are 2 cycles over here. What I am saying is try to understand the point. Don't do always the integration, right? Sometimes it's very easy to draw the graphs and write down the answers there. Now, what you are saying, you are going to integrate it over one time period. Let's say take some time period. Let's take from here to here. So I'm just choosing one time period like this. Here it is there. So one time period is this one, right? So let me just take it. Let's say from here to here. This is one time period. This is integration time period. We are interested in integrating this cosine wave for this much duration. What you will see? There are some positive areas. So this is a positive area. This is a positive area. This is a positive area, right? So these are positive areas. What are the negative areas? Negative area will be this, correct? And this. So it might not looking exactly same. The black one is a positive area. The black one is something positive area, right? So here also some portion will be there, like this. So this is a half cycle positive area. This is half of half cycle, means 1/4 of the complete cycle. This is 1/4 of the complete cycle. So 1/4 will be half, and half will be one positive cycle, positive area. And this is something when I showed it in green one, they are the -1 cycle. This is half cycle, this is half cycle. So one cycle completely negative area. So this is what I am saying, that how much positive area you are accumulating with the same area you are going to accumulate in the negative direction. So positive area and negative area are exactly same. So the integration is nothing but area, right? To find out the area under the curve. So this is going to be 0. This is what I have written there. So anytime you get an integer multiple of this time period T naught, and you are integrating over one time period or maybe integer multiple of time period, then definitely this cosine wave will give you always 0. And this is a sort, I should say, the reason why this should be 0, right? Graphically, I should say, graphical way of telling that this integration should go to 0. You can always do the maths and do the integration cos. The integration of cos is sine, and then you can put the limit and you can give the answer that it is 0. So, but this also should be known to you. That is what everybody should think in this way, right? Because it is useful in many aspects. Okay, I hope this is clear. The power of a cosine wave is going to be, with some phase, it's going to be 0. Remember, this f0, the time period, the frequency should not be 0. If it is 0, then this is going to be not a sine wave, but it is just going to be a DC signal in that case. If the frequency is 0, then it's a DC signal, right? And for DC signal, the power is not going to be a square by 2. It will be different, right? One can figure out. We will see that also later on. Now let me just take the second problem, and you please try to solve this problem. This time let's take a complex signal, right? We took one real signal. Now let me take a complex signal. A e power, let me write plus minus j, right, 2 pi f naught t plus theta. So this is a question. Let's just take, for the time being, let's take only plus, and after that we will include this minus also, because this is same problem. Whether you take plus or minus, the power will come out to be same. Let's take this time plus and solve this problem. We call it complex exponential signal, right? We call it complex exponential signal. Right. Okay, just take 5 minutes and solve this. We should be quick, right? We should be fast in doing it. We are doing very simple problems, but they are going to play a very important role when you are going to understand the difficult problems, right? If you get the answer, just respond. When I am doing the solution, I am doing slowly, because so that everybody should follow. which you can do in second actually, right? It does not require to go step by step when you are solving, but when I solve, I go slowly. Did anybody get the answer?
Sir, is it 1 plus j by 2 times I square?
Power is coming to be negative. How it can be negative? When you are going to integrate, power cannot
No,
be
sir.
here in this case.
Yeah, it's not negative, but 1 plus j by 2 times a square.
That's what I'm saying. It cannot be imaginary, I should say. Complex. It cannot be complex.
Okay, so I will check it.
Okay, the very first thing, is it a periodic or not? Is it a periodic signal or not? That's the first question, right? Because you have got two formulas. One is only applicable to periodic and one is applicable to both. The very first thing you have to figure out, is it a complex, is it a periodic or non-periodic signal?
The periodic one, sir.
Periodic one. And what is the time period here? 1 upon f naught, correct?
Yes, sir.
Everybody following this point? This a e power j.
Yes, sir.
2 pi f naught t plus theta. It's a periodic signal. Is a periodic. It's a complex periodic signal, right? With time period t naught, which is 1 upon f naught. And the rest of the thing is very simple, right? You just have to apply. It is a complex, so you have to take the mod here. Should I do it? Okay, let me do it just. Minus t naught half to plus t naught half e power j 2 pi f naught t plus theta, and I have to square it, right? So this will be mod square. So I forgot to write a there, right? So let me just write a over here, a square. Here we are saying a is a positive real quantity. Yeah, it can be take positive or you can take negative also. It can be just think like it's a real number, right? A is real number. It's not a complex. Okay, a square by t naught minus t naught half square d t. Oh, okay. It's a one-line proof only, right? What is this? Can anybody tell me what is e power j? Let's say e power j and something. Let's say j. Let me just write u. Let's say, and take the mod. What is the mod of this? How to calculate the magnitude?
One, sir.
It's a 1, right? Very nice.
Yeah.
It's a 1. 1, good. It is 1, right? And when you square it, it will be 1, right?
Yes, sir. Yeah.
So what do you get here? When you take mod, you get 1. So this will be simply a square by t naught minus t naught half to t naught half, and this is 1 dt. When you integrate 1, what do you get? T. The limit will be minus t naught half to t naught. It's just one line proof, right? I'm just writing them step by step, but that's not required. So t naught half minus of minus t naught half. So this become plus. So t naught half will be t naught, and this t naught is there in the denominator. I can directly cancel them here. Half and half is 1. So you get a square. A square. It's a very nice that result, I should say. Everybody start remembering this answer. Why I'm saying? Because every time you should not solve this problem of getting power. So there are some standard signals whose power you should remember it. Like you remembered the, let me just write them, right? So when I have power of a cos 2 pi f naught t plus theta, its power we just calculated a square by 2. Yeah, this everybody knows already, right? But what I'm saying is one should remember this, and f naught should not be 0 in this case. So this is important. And then power of a e power j 2 pi f naught t plus some angle theta, and let me write plus minus as well, because minus eventually it becomes also plus. You will get 1 only, right? So you'll get a square. See? And again, f naught should not be 0. Unless and otherwise, I will, A is a real quantity. It should not be complex quantity. Here A is a real quantity, A is a real quantity, right? Okay, I hope this is clear. These two formulas, you can take them as a formula, I should say. Right, once we solve this derivation, we should remember them, right? One more thing, I don't know how many of you are knowing or not Euler's identity. So everybody also should know that. So that I'm writing here also. You can also write them. What is Euler's identity? We have e power some j theta. So we can write it like, let me write a e power j theta. So we write it what? A, we are assuming A is a positive quantity. Positive real quantity, I should say. Then we write A angle theta. Some people also write it cos theta plus j sin theta. And this is A cos theta plus j sin theta. Right. So this all things are exactly same. So whenever we write this kind of notation like A power j theta, then sometimes we will break this A power j theta into cos and sine. Sometimes we have cos and sine and we want to break it into A power j theta. And electrical engineer, they like this notation. When they work with the network problems, they write this kind of notation. So this should also be known to everybody. I hope this is clear that this identity is important. Many times you will see this notation that we are going back and forth between these three notations, I should say. I hope this is clear. Now let's move to another problem which we have. Yes, somebody is saying something?
Yeah, so could you please elaborate how the function which we were given is a periodic function, because I was not able to understand that point.
Okay, no issue.
Yes, sir.
Just think like a e power j, and just let me write 2 pi f naught t. Just let's forget about theta for the time being, because it's just a phase which is just going to shift the origin, right? Theta is there to just shift the origin. Otherwise, it's not going to affect anything over there. So let's just concentrate on this e power j 2 pi f naught t. And when I write it, just there are many ways that you can prove this, right? Let me write Euler's identity. I can write cos 2 pi f naught t plus j times 2 pi f naught t. Now what we are saying, this is a periodic signal with time period t naught. This is a periodic signal with time period t naught. So this is, when you see this real part of this, it is going to change or oscillate with time period of t naught, and its the imaginary part is also going to oscillate with time period of t naught. So overall, this complex signal will be a time period periodic signal with time period t naught. Is this argument understood?
Okay, so got your point.
Okay. There is another way that you can prove it by the definition of periodic signal, right? So any periodic signal, you can prove it like this. So we are saying if it is periodic, then after the time period, it should repeat, right? So means whatever is going to happen at t plus t naught will be exactly same as what will happen at exactly t. Am I correct? Because whatever I'm getting at t, the same value I should get at t plus t naught. Is this correct?
Yes, sir.
Okay. So just you have to what compare this left hand side and right hand side. So let's do that. E power, I can take this t plus t naught. It's in the bracket. So just open this bracket. You will get e power j 2 pi f naught t, and then I will have e j 2 pi f naught, and this is the t naught that I'm writing. Now what do you see here? F naught and T naught, they are inverse to each other. So this and this will get cancelled. So you'll get only e power j 2 pi. So e power j 2 pi and e power j 2 pi f naught t. And what is e power j 2 pi? It's a 1. So I am just concentrating on left hand side. And this is, I wish to prove, if it is periodic. If it is periodic, then I have to prove this, right? This thing I have to prove. So for that, I have taken left hand side and just figured out that e power j 2 pi is 1. Why it is 1? Because e power j 2 pi is nothing but cos 2 pi. It's complete one rotation, right? And j sin 2 pi. Sin 2 pi is 0, cos 2 pi is 1. So you'll get e power j 2 pi is 1. So this is nothing but left hand side. So what I can say, according to the periodicity, whatever happening at time instant t, the same thing is happening at t plus t naught. So that's why it's a periodic with time period t naught. This is another way of explaining this periodicity of this signal. Is it understood now?
Yes, sir. Thank you,
Okay,
sir.
so we will see this periodic signal and non-periodic signal, a class of signal, when we learn classification of signals. There we will learn there, right? So how to calculate how to find any signal to be periodic or not. And if it is periodic, what is it? It's a time period. That's also we are going to find out, right? So don't worry about that. But at present, we need some kind of understanding here that is it periodic or not, because the formula relies on this thing. The first is to find out is it periodic or not. Okay, so we got two formulas. Now let's just take one more signal, which is complete DC signal. So let me just write. Well, let me draw it for you, right? So sometimes graph, instead of writing analytically, better to draw a graph of a signal and do this question, right? So it's what, let's say the amplitude is A, it's a constant. Throughout timing, a time is a constant. So at any time you see the signal, it's a constant, its value is A. You can see it's like a DC voltage source. So this is a kind of signal which we call it DC signal, which is a constant throughout the time. No matter at what time you will see, it will be 1. At infinity, A. At infinity time, it will be A. At minus infinity, it will be A. Okay. So we are finding the power of this signal. The very first question, what is it a periodic or not, right? Is it repeating? Or if it is repeating, what is the time period?
So we can call it a periodic function having period t is equals to 0.
Okay, so this argument is something like what, when you say periodic signal, then it should be a non-zero time period value, right? It should not be zero a time. It should not be zero time period, because periodicity is something what you have to find out the minimum time period for which the signal will be periodic. Means it should have some changes and then it will repeat. Are you getting my point? And one signal which is not changing at all, we don't classify them as a periodic signal. You can say it is a periodic signal with time period 0, but whenever we say periodic signal, we say the time period should be non-zero value, right? It should be a non-zero value. Is this point clear?
Yes, sir.
Okay, so we got this A and we want to find out the power of this signal. So we can apply the limiting definition formula, limit capital T tends to infinity, 1 over T minus T half to T half, and then we have mod of xt square dt. This A can be complex also. Now in this case, this A can be complex also. Okay, just concentrate that this is something what a real value, let's say, for the time being, right? So it can be complex also, by the way. Okay, let's see. Limit T tends to infinity, 1 over T, and I have minus T half to T half. A is there, so this will be A square. So I'm assuming A is a real quantity, right? Real constant. Otherwise, I have to find out it's a real part and imaginary part and then do the things over there. So this A square is a constant. You can take it outside of this limit entirely. So this is limit T tends to infinity, 1 over T minus T half to T half, and we have to integrate 1. So we get this integration, we are getting it again and again. So this will be T, and when you do this, what do you get? A square limit T tends to infinity, 1 over T, and this will be T half minus of minus T half. This becomes capital T. This and this got cancelled. So you get A square limit T tends to infinity 1. So this will get A square only. So power of a DC signal, it's a square. It's something what it is a square of the DC value. So A is a DC value, and we were interested in calculating the power, right? So power in DC signal, A like this, it's A square. So you can say it's a DC power actually. I got one name, DC power. So sometimes in electronic devices, you might have seen that I have a DC supply of 10 volt. So if somebody asks you what is the power in that DC supply, if it is 10 volt, it will be just 10 square, that is 100. Right? I think this is clear that what is the meaning of this DC power, right? Power of a DC signal, it is what? Signal square itself. And let me just write that also. P infinity of A DC value, it's A square. And what is the RMS value? It will be A, right?
Yes, sir.
Yes.
And it's a DC value also. So what I can say, if somebody asks you, what is the RMS value of a DC signal? I will say it's a DC value only. Right? It is not true for other signals. It is not true for other signals. This is a special case. You can say that DC value is itself RMS value. DC value itself, it's a RMS value, right? So this is what the DC signal or the DC signal power that we calculated now. This is a very simple proof that I did. Now let me go back to the problem there, the previous problem. What we did, we calculated power of A cos 2 pi f naught t plus theta, and we said it's a square by 2. Just concentrate on this. If I won't write f naught should not be 0, what will happen to this problem? If I suppose in this case, if I assume f naught to be 0, let's assume that and try to see what will be the formula. So I will get P infinity A cos theta, and the power I am getting is A square by 2, which is a wrong one. Why I'm saying this is the wrong one? Because this a cos theta, it's a DC value. For a particular theta, you choose some theta, 30 degrees, 70 degree, pi by 2, pi over 2, pi by 3. In that case, it's a DC value, so the power cannot be a square by 2 in this case. Am I correct? Is this clear?
Yes, sir.
Yes, sir.
So this formula is applicable when f naught is not 0. If f naught is 0, because I can give you any frequency, I can give you any angle, but if I give you a frequency with 0 hertz, and you will say that I can write this a cos theta as like this, and I can say that f naught is 0, then what will happen? Then you will say a square by 2. The answer is wrong, right? I hope this is clear. What should be the power of this? The right answer will be square of this. A square cos square theta. Am I correct? And this can be like a square cos square theta. And just assume that theta is pi by 2. What will happen to this? This will go to 0. Right? If theta is pi by 2, then this will go to 0. Theta is pi by 2, then this will go to 0. Right? So you are making mistake when you are saying this is a square by 2. It's not a square by 2. In that case, it will depend on theta as well. That I mean to say. In this case, the power of sinusoidal signal is independent of theta. It's independent of frequency till frequency is non-zero. If the frequency is 0, then this power will depend on the theta value. I hope this is clear, right? And similarly, we took that as a power of what we took, power of e power j 2 pi f naught t plus theta, and we got that answer as a square, right? And if suppose f naught is 0, what will happen? You will say, sir, this is p infinity of e power j theta. What is the power of e power j theta? E power j theta is a complex constant. Am I correct?
Yes,
it's
sir.
a complex constant. And what we figured out, p infinity of a, where a is a real constant. Then I got it to be a square. Correct, no? This is that problem we focused on here. A is a real constant. I got this as a square. But what will I have if I have a is a complex or e power j theta kind of thing? What will happen to this? You are saying the answer should be a square, right? But what will happen to this? Let's just see this. Let's apply the formula. Let's calculate the power in this e power j theta. Right?
So shouldn't it be a square e to the power 2j theta?
Power cannot be complex. Remember, power formula itself is what? It's this one. Let's just focus on here. See the formula and you tell me, can it be complex number? If you write xt mod, when you write xt mod, xt is a complex. When you take mod, will it be complex then?
No, sir, it won't.
So there is no way that you can get a complex power in this case, I should say. Value of power has to be real number only, right? Because the formula is this one.
So then it will be a square, right?
See what will happen. E power j theta square dt. So we should always worry about this complex and real quantity, because in physical situation we may not get complex, but in the problem of signal system, it's very important, or you have to be cautious when dealing with this formulas. You should know that this is true for every complex or maybe real, but this is what you need to understand, right? Let's see that. You say a square, so this will be a square will be common. E power j theta, whatever it will be 1 minus t half to t half. This will be 1 dt. So this will be a square. I hope this kind of thing we have already done. Here I am getting a square. No matter what the value of theta is, theta can be 0, theta can be infinity, theta can be any value here, by the way, right? So it does not depend actually. So let me go back and do that. What we said here f naught can be 0. I wrote it there, right? So f naught can be 0. So I just need to remove this. Got this point? Yes. Did you got this? Did you get this point?
Yes, sir.
So we got the meaning of this. I hope this is clear. Okay. So some kind of treatment must be needed whenever you are doing this kind of things. Okay, that's fine. Now, what will happen if it is a e power j, or let's say minus 45 degree? What will happen to this? What is this? This is cos 45. Okay, this is imaginary only, right? You don't have to do that. Fine, no problem. Okay, so let's you solve this problem now by yourself. So let's say I have a signal which is not completely, I should not say it's a DC signal, it's a unidirectional signal, right? We call it unidirectional, one-sided signal, and flat also. This is T, this is 0. At time t equal to 0, let's say the value is A, and let's say the signal is this one. This is question number 4. People call it unit step signal or a step signal. Unit, if height is unity, we call it unit step, otherwise we can call it step signal. You will learn about this unit step signal in the next topic or next session, but let's just try to see what could be the power of this signal. Unit step signal. Okay, definitely it's not a periodic, right? To be a periodic, the signal should start at minus infinity and it should go to infinity. I repeat this argument. To be a periodic signal, signal has to start at minus infinity and it should go forever, means till infinity. Otherwise, the signal cannot be periodic, right? While drawing periodic signal, we draw only 2 to 3 cycles. But in that case also, we mean that the signal is there, though we have not plotted it, right? Because nobody can plot it for infinite time duration. Otherwise, your page will be a smaller one in that case. Okay, fine. So just calculate the power of this step signal. Once you solve that, then you solve this problem, which is another one very useful problem, I should say. Has anybody calculated it?
Is it a square?
What is it?
A square?
A square. Else, who got the answer? A different one or same one, whatever it may be. So somebody is saying A square. See, don't get discouraged if you get the wrong answer, right? So this is my one suggestion. Don't get discouraged if you get wrong answer. Unless you make mistakes, you will not learn. Yes, I got only one answer. Any other answer?
Yes, it should be A square because it can be treated as AC, like DC from taking a 0 as the beginning. So yes, sir, A square should be the answer.
A square should be answer.
A square by 2.
A square by 2. I got two answer now. A square by 2. Any third answer? I think many of you are getting A square, some of you are getting A square by 2. Let's just do this if it is possible to do it. This is the formula that I need to apply. And this is limit t tends to infinity. But from minus t half, if you see negative, it's all 0, right? So this signal is all 0 before p equal to 0. So this is all 0. And this is a after t equal to 0. So this will be simply 0, t by 2. And after this, this is just a square dt. So a square is a common. Then you get 1 upon t. And then you get t by 2 minus 0. T and t got cancelled. And you get a square by 2. I don't know why you're getting a square. Did you get that? This is a square by 2?
Yes, sir.
Okay, so this is a square by 2, right? Okay, fine. So now let's just solve this problem. So for all, this px1 is very easy, right? Px1 we have already calculated. How much it will be? A1 is square by 2. And in this given problem, omega 1 and omega 2 is not equal to 0, omega 1 is not equal to 0. They are not 0 frequency, right? So definitely this will be an square by 2. This will be a2 square by 2. What about this? Is it a1 square by 2 plus a2 square by 2? Right? Is it a1 square by 2 plus a2 square by 2? This is, we have already calculated, right? The first problem was this one only, A and B, that I solved now. I am just writing that. What will be this px3? You all can do this calculation, but people started thinking like what, sir, x3 is given x1t plus x2t, but first we need to find out whether this omega 1, this x1t and x2t are periodic or not. Right, let's just assume that omega, this x1t and x2t are not periodic. Oh, sorry, x1t plus x2t is not periodic. See, my point is this one. You are saying a1 cos omega 1t plus theta 1 plus A2 cos omega 2t plus theta 2. So we start split over here that is it a periodic? It's a periodic. Is it a periodic? It's a periodic. What is the time period? It's a 2 pi by omega 1. What is the time period? It's a 2 pi by omega 2. This is how omega and time periods are related. 2 pi t naught. Right. Then we are asking, I got two periodic signals and I am adding them. So the addition will be periodic or not? That's the first question that will come in our mind, right? So anyways, let's assume that these are not periodic signals. Let's say the sum is not periodic, right? Because I need to talk about how to calculate, how to see if the signal is periodic or not. So, and once it is done, then we need to figure out if it is periodic, then what is the time period? Because one is having time period of 2 pi by omega naught and one is having time period of 2 pi by omega 2. So when you add it, there should be only one time period, right, for which the sum will oscillate. But in general, it may be, it may not be periodic. So just take it for granted for at this moment and just assume that it may be periodic, it may not be periodic, right? So if I don't know that whether it is periodic or not, then which formula I should go with? I should go with the first formula, right, which is applicable to both periodic as well as aperiodic. Am I correct? Is this point clear? Since at present I don't know that this signal is a periodic or not, this sum is periodic or not, so I should go with what? Formula of power, which is for a periodic signal or non-periodic signal. Is this clear? Because if you tell me, sir, this is a periodic signal, then I will ask you what is the time period then you will take. One time period you have to take it, right? In the formula it is 1 upon t naught minus t naught half to plus t naught half. So I will ask what is t naught then, right? So since that is a different class of problem that we need to deal it in the next section, next session. So at present, let's assume that the sum is not periodic, and we can use the first formula to solve this problem. Can you solve this problem? Just give it a try and try to see if you get the answer or not. So that is the limiting definition to calculate power. So this will be x3t, which is eventually x3t, and this is a real quantity, so this will be just a square dt. Limit t tends to infinity 1 over t, and this is x3 square, so I have to add this 2 and square it. So minus t half to plus t half, this will be a1 cos omega 1t plus theta 1, and then I have to add with this a2 cos omega 2t plus theta 2. You also solve it side by side. Don't look at my solution and solve. You solve it by your own, and then if you get stuck somewhere, then we will. You can see here, right? But at present, just you solve it by yourself. This is the limit t tends to infinity 1 over t minus t naught t half divided by t minus t half to plus t half, and just square a square plus b square plus 2ab formula. So this becomes a1 square cos omega 1t plus theta 1, that is square. This is the first term. Then I have the second term, which will be minus t half to t half a2 square cos square omega 2t plus theta 2 dt. Then I have the third term, which will be 2ab, right? So this 2 I will take it common. So minus t half to plus t half, and this will be a1 a2. So this becomes a1 a2, and then I have cos omega 1t plus theta 1 times cos omega 2t plus theta 2 dt. So there are three terms. You can see this is a very big pictures over here. Okay. So limiting of this 3 integration, let me just write it like this, that limit t tends to infinity 1 over t, and let me write minus t half to t half a1 square cos square omega 1 t dt. And just remember, when I am going from this step to this step, that I am assuming by default that limit of sum is a sum of limit, right? Limit of sum is a sum of limit. Are you getting my point? So from this state to this state that I am going is I am writing limit of sum is a sum of limit. So I have 3 limits actually to apply. So you have to be a little bit cautious when you are applying the limiting things, right? Cos square omega 2t plus theta 2 dt, and the last term is plus limit t tends to infinity 1 over t, and this is 2 a1 a2 minus t half to t half, and this will be simply cos omega 1t plus theta 1 times cos omega 2t plus theta 2, and then dt. This is the multiplication, right? So there are 3 terms. Now just look at term by term. If you see this first term, what is this? This is the power of, what is the power? This is the power of a1 cos omega 1 t plus theta 1. Am I correct? This first term is the power of a1 cos omega 1 t plus theta 1. You just can see this a1 cos omega 1 t plus theta 1 square, and then you are applying this formula, right?
Yes, sir.
So this is power of this. What is this? This is the power of this. So I'm not solving it because every time we don't need to solve it, but this is one good thing to solve this problem once. Why I'm saying? Because this is the formula to calculate power for both of the signals, periodic as well as non-periodic. But for calculating the power of a1 cos omega 1 t plus theta 1, we calculated by using formula for periodic only. But this is the this formula is true for the first formula is true for both periodic as well as not periodic. So one should solve it once in a life at least, right? So that point I should not forget to mention, because we need to prove it that this power is actually a2 square by 2. So that's what I'm saying. And now we have this third term to calculate, right? I will come to that third term again. So this will be simply a1 square by 2, because we have already know it. This will be a2 square by 2, and the third term which is there, what this will be? The third term is a little bit trickier one. It is the area under the product, and we are finding this one, right? So let's third term, let me write it like this, third term, because we don't know now at present what is the third term going to be. So let's write the third term here. Third term is what? Let me take constant, this a1, a2, and then I have limit t tends to infinity 1 over t. It's a minus t half to plus t half cos omega 1 t plus theta 1 cos omega 2 t plus theta 2 dt. So there is no way that we can expand it cos A cos B formula. So that is first need to apply limit t tends to infinity 1 over t and just cos A cos B. What is the formula to have cos A cos B?
Cos A plus B plus cos A minus B by 2.
Okay, so cos A plus B will be omega 1 plus omega 2 t plus θ1 plus θ2. This is first term, then second term will be cos omega 1 minus omega 2 t plus θ1 minus, θ1 minus θ2. And I can just separate this two integration. Right. Okay. What do you say when you integrate any cosine wave? You should get a finite area or what? Yes. Whenever you integrate any cosine wave, I am just going to write that argument, because now at this moment I am going to write the argument. We will not be able to prove it mathematically, but we can prove it graphically. Yes. Anybody can tell me? If you integrate a sinusoidal
Infinite.
Infinite. Why? What is the maximum area that you can get? Will
Zero.
you get infinite? 0. Any other answer to this? Let me just tell you that what we can get. I have a cosine wave, and here t naught, t and this t half, these are not time period, right? By the way, I have some cosine wave operating at frequency omega 1 plus omega 2. Let's say that this frequency is omega 1 plus omega 2. So this oscillation is omega 1 plus omega 2. And let's assume that the time period is somewhere minus t half to plus t half, right? So I just write it. No matter what you do, right? You can expand this time period or everything. Let me just go here also. And let's try to do that. So here to here. How many positive areas are there? Let's just locate. 1, 2, 3, 4, and 4.5. Sorry, 1, 2, 3, 4. 4 half cycle, and this is 1 quarter cycle. So means this is 2 complete cycle and 1 quarter, right? 2 complete cycle. Let me write that in words there. 4 half cycle. Half area, let me write. Half cycle area. Positive thing I'm writing, right? Plus 1 quarter cycle area. What about negative area? 1, 2, 3, 4. Means 4 half cycle area. The green was the negative area, right? And this one also there. 1 quarter cycle negative area. What you'll get? Exactly same. This negative area will cancel with this positive 4 cycle area, and this will be cancelled because of this one. You get 0, right? For this particular choice of capital T. For this particular choice of capital T. But it is not necessary that capital T will be like this only, right? Have you got this point?
Yes, sir.
Yes, sir.
At most, how much you will get?
So
What do
a
you
half
think?
cycle area.
Yes, at max I can get a half cycle area, positive half cycle area, and at minimum I can get negative half cycle area. So no matter I will do, I will have a finite area. Am I correct? I have a finite area. Am I correct?
Yes, sir.
Very nice. So no matter I will do, I will get a finite area. So this is just for argument. Okay, let's do it now. Now we are saying in this limit, t tends to infinity, no matter how much t you will choose, this integration will come out to be finite. Is this point clear? Yes?
Yes, sir.
And this integration will is also going to be a finite in the same manner. Now what you have is as follows. So I have talked about only this one. Now let me write this A1, A2, limit t tends to infinity, I have some finite, let's write finite 1 divided by t, and then I have limit t tends to infinity, some finite, let me write finite number 2 divided by t, and when you apply the limit, what will happen? Finite upon
So it would
what this
become
will be? It should be
0.
It should be 0, right? So if these two things are 0, then this will be 0. So the third term that I just said, it is basically 0. So what do you get? The total power is power of first sine wave plus power of second sine wave. It is something what I should not make it generalized, right? Power of sum of two signals is the sum of power of two signals. It's not like that. So eventually what we got? We got as follows. Sum of two signals, x1 and x2, it comes out to be px1 plus px2 provided x1t times x2t dt, again minus t half to t half, limit t tends to infinity 1 over t, it should come out to be 0. Is this point clear? Yes? Is this point clear?
Yes, sir.
So this power of sum is a sum of power if and only if this condition is satisfied. This condition is called as orthogonality condition. So this is the first time I'm using this word, orthogonal. Like in vector we have dot product. We say that two vectors are orthogonal if the dot product is 0. Right, they're perpendicular. So in signal also we have this kind of nomenclature, technical terms I should say, orthogonal. Signals should be orthogonal. Okay, this is just for tell you that this is for what? For sorry, what I'm doing. So I'm not writing now for the timing. Orthogonality we will learn it later on also, so we will not confuse ourselves in this, but provided some condition, right? This condition is this one, area under product you can say, and divided by the time. This is what there. I hope this makes sense. Now let's revisit the problem again. Here this comes out to be a1 square by 2 plus a2 square by 2 provided omega 1 is not equal to omega 2. Right? So first of all, this should be there. Frequency should not be 0 to have this formula. And here also, this power of sum is sum of power. Omega 1 does not equal to omega 2. Now I will suggest you calculate, let me just delete this some of those things over here, calculate px3 when omega 1 is equal to omega 2. In other words, if these two frequencies are exactly same, but they are having different phase, one is having theta 1, one is having theta 2, at the same time they are having different amplitude, right? But omega 1 and omega 2 both are same. In that case, what will happen? What will happen? So this is a D, point number D. So what I have, x3t, which is a1, and let me write cos omega t plus theta 1 plus a2 cos omega t plus theta 2. Now in this situation, what I made, omega 1 and omega 2 are equal, right? This is what we said. This is a nice problem now. Okay. Can anybody solve this problem? This is a very simple problem, right? You have to combine this two term into one term first. So let me just give you the hint over there. Combine both the term into one term, because both are having same frequency, so you can combine them, right? Both are having the same frequency, so you can combine them actually. If you don't combine, then also you can find the solution. It's not a difficult task, but okay, you can use this hint if you want. If you don't want, then also you can go with that, right? If you know this, how to combine two cosine wave of having same frequency, then it will be better. If you don't know, then also it's not a problem, right? This is the last problem that we are doing today. Or you can just apply the previous one. That would be better, much better than this. Will you do it, or should I do it for you? Here is the catch, right? Where is that? The third term, which we made it 0, right? The two term will definitely come, a1 square by 2, a2 square by 2. There is no doubt in that, right? The only thing is what? The third term will be different in this case. Should I do that? Because I just need to copy it and paste it there and solve it for you. Should I do it?
So we could try it.
Okay, you just try it then. I copied it, but where it went? I think this went down. Here it is there.
Sir, is it a1 square by 2 plus a2 square by 2 plus theta 1 minus theta 2?
Okay. You got the first two term correctly, because that has to be. The third term is a little bit different. Your approach is correct. This is related to just class C, the the problem number C only. You just look at it, right? Because time is up. I think this is 6 o'clock. So we will not. You just see here, right? See what we said. This is something class number, question number C, right? Okay. Look at here and you will get everything there, right? So just assume that omega 1 is not equal to omega 2 for time being. That we did just exactly same in problem number C. And we got this a1 cos omega 1 t plus theta 1, a2 cos omega 2 t plus theta 2, and we squared it. So we got three terms. This was the first term, this was the second term, and this was the product term, integration of product term. There we got three terms. So, and we recognize that this is a1 square cos square omega 1 t plus theta 1 dt. It's a power of a1 cos omega 1 t theta 1. Now you are saying omega 1 is equal to omega 2. So whether it is omega 1, omega 2 or some omega, the power is going to be a1 square by 2 for this first term. So there is no doubt about this. In the second term, the power has to be a2 square by 2. Again, omega 2 here we are taking in problem number D as omega 2 equal to omega. So this will be a2 square by 2. So that there is no problem with the term number 2. But term number 3 is now we have this one where omega 1 is equal to omega 2. Omega 1 is equal to omega 2. So this will be cos omega t plus theta 1, cos omega t plus theta 2. There is a multiplication. Okay. So third term, how we solved it? Now let me go to third term right here in the next section over here. This was the third term. So I should get what I should get? I should get a1 square by 2. I should get a2 square by 2. And I should get the third term, which was 0 in solution C. Now this is problem number D, right? Now what I will do, I will write omega 1 equal to omega 2 and do that. Okay, so now just look at here. Let me just zoom out a little bit. Okay. Now see this here. This is omega 1, I should replace with omega. This is omega 2, I should replace with omega. So I will just write one piece of line of code over here, or sorry, not code, but the things. So here is the catch. This is 2 a1 a2 limit t tends to infinity 1 over t, and this will be minus t half to t half, and this will be cos 2 omega t plus theta 1 plus theta 2, and this will be dt plus this is the term that I have minus t half to plus t half. Omega 1 and omega 2 both are same, so omega 1 minus omega 2 will be 0 because omega 1 and omega 2 are same. So in this line I am replacing omega 1 with omega 1, omega 2 with omega. So this will be 0. So this will be cos 0t, and theta 1 minus theta 2, I will write that. This will be dt. Is this correct? Is this correct? From here to here, how I go to that point? Yes? Is this point clear?
Yes, sir.
Okay. So what we said earlier is still true for this case, that cos 2 omega t plus theta 1 plus theta 2 dt, this is going to be a finite. So I have two limits to work with, a1, a2, and this is limit t tends to infinity 1 over t, and this is a finite. So this is the first term. I should write here like this. Okay, and the second term will be limit t tends to infinity and 1 over t, and just check out here what this is. Cos theta 1 minus theta 2 is independent of time. So this will be something cos theta 1 minus theta 2 outside of integration. Then you have 1 to integrate from minus t half to plus t half. So you will get t half minus of minus t half, right? So this will be t, capital T. Now what do you have? Are you getting the point over here? What is happening over here? This will be 0. What about this? This t and this t got cancelled, and you have what? Limit t tends to infinity cos theta 1 minus theta 2, and there is no t to put the limit, so it will be just limit of a constant is a constant itself. So this will be simply 2 a1 a2 0, and this one will be cos theta 1 minus theta 2. So what you get? The third term is 2 a1 into a2 cos theta 1 minus theta 2. So the final answer would be, this is third term, right? And the third term is nothing but a1 square by 2 plus a2 square by 2 plus 2 a1 a2 cos theta 1 minus theta 2. omega 1 is equal to omega 2, that is omega, and that is not equal to 0. So in that case, the power will be this. I hope this is understood, everybody. Is this point clear?
Yes.
I hope this is clear. This is understood, everybody, that how I am calculating the power of sum, right? So
Yes.
what I'm saying is, today what you have seen is a lot of exception that we dealt with, right? Means we are solving the problem, but at the same time we are trying to understand what can be the exceptions, right? Because there are a lot